We have our first speaker for today. I request the student chair of IEEE GRSS SBC MIT, Mukala Smritika, to introduce the speaker for the guest.
Good morning, everyone. I'm here to introduce the first speaker of the workshop, Dr. Shashi Kumar. Dr. Shashi Kumar received an MSc degree in physics from Patna University, Patna, and an MSc degree in geoinformatics under the Joint Education Program of IIRS Dehradun and ITC Enschede, Netherlands. He also received his PhD from IIT Roorkee. He is currently a scientist in the Indian Institute of Remote Sensing ISRO, Dehradun. He is actively involved in the science team of NASA ISRO Synthetic Aperture Radar and ISRO Chandrayaan-2 missions. He has worked as a member of the task group for SAR models for the forest parameter retrieval under the partnership of Government of India and the United States Agency for International Development Forest Plus program. We welcome you, sir.
Thank you for providing this opportunity to deliver this talk.
Sir,
Yes.
Sorry for interrupting. With
Yes.
due permissions, can we record the lecture?
Yes,
Okay.
sure. Sure.
Thank you.
So, good morning all. Today we are going to have a session on fundamentals of synthetic aperture radar remote sensing and its applications. So, first we are going to talk about synthetic aperture radar remote sensing. So, synthetic aperture radar remote sensing is an active imaging remote sensing technique in which radar sensors are used to acquire the data set of the landscape. Now, synthetic aperture radar remote sensing is carried in the microwave region of the electromagnetic spectrum. So, this is coming under the category of the microwave remote sensing. And the synthetic aperture radar remote sensing is an imaging active microwave remote sensing technique which is used to generate high spatial resolution data set. When we are talking about microwave remote sensing, so the remote sensing which is carried in the microwave region of the electromagnetic spectrum is known as microwave remote sensing. So this is the microwave region of the electromagnetic spectrum, and the different bands in the microwave are given here, like K band, X band, C band, S band, L band, and P band. So there are different wavelength ranges. When we are moving from K band to P band, there will be increase in wavelength. Now we are knowing that wavelength and frequency both are inversely proportional to each other. So when there will be increase in the wavelength, there will be decrease in the frequency. Now longer wavelength ranges are used for those applications or in those areas where there is requirement of high penetration capability, like long wavelength ranges, they will have capability to penetrate higher in comparison to the short wavelength ranges. Now, if we will compare it with the optical multispectral data set, so optical multispectral data set, so from the name it is clear that optical multispectral, it means that one data set will have the multi-frequency information. But in the case of SAR remote sensing, so radar sensors, they are highly coherent and monochromatic. So that like one SAR sensor, one synthetic aperture radar sensor is going to provide the data set in one frequency range only. Suppose the sensor, any sensor is launched in C band, so that sensor is going to provide you the data set in C band only. Like here, if you will see, the wavelength range of C band is 3.75 to 7.5 centimeter. So generally 5.4 or 5.5 or to 5.6 centimeter is used. One wavelength will be used to acquire the data set and to design the sensor also. So we can see that there are several bands within the microwave band in which the remote sensing is carried. Now, when we are talking about microwave sensors, so synthetic aperture radar remote sensing is an active remote sensing technique But microwave sensors are again categorized in two categories: passive microwave as well as the active microwave. So passive sensors are those sensors that cannot generate their own energy. They are completely dependent on any other source. So here, if you will see the passive microwave sensor, so a passive microwave sensor detects the naturally emitted microwave energy within its field of view. So here the word, when the word radiometer is coming, so this radiometer is a passive microwave sensor which captures the emission in the microwave region of the electromagnetic spectrum. So there are several applications of the radiometers, or we can say the passive microwave remote sensing. These applications include the meteorological application, hydrological, as well as the oceanographic application. To find out the sea surface temperature as well as the land surface temperature, and as well as in the glaciological application. And there are many more applications of the passive microwave. But here we are going to mainly restrict ourselves to active imaging. So when we are talking about the active microwave sensor, so again, active microwave remote sensing is categorized in two categories: imaging and non-imaging. So for the imaging purpose, radar sensors, or the radar is an acronym for radio detection and ranging. So radar sensors are used to generate the high resolution two-dimensional images, and after doing the processing, one will be able to generate three-dimensional images also. Like here, if you will see the remote sensing, so generally for the Earth observation, visible range of the electromagnetic spectrum, that is covering 0.4 micrometer to 0.7 micrometer. Then reflected infrared, that is 0.7 micrometer to 3 micrometer. And then thermal infrared, that is covering approximately 3 to 14 micrometer. And the microwave region, that is covering approximately 1 millimeter to 100 centimeter wavelength range. These are used in the remote sensing. Now, if you will see, in different remote sensing technique, different characteristics or different properties of the electromagnetic wave is used. Like in the case of optical multispectral, mainly the concept of a reflection is used, a reflection of the electromagnetic wave, like all the energy which is coming from the sun in visible and reflected infrared will be reflected by the earth object, and it will be captured by the sensor. So finally imaging will be done, and geo and biophysical parameters will be received based on the reflection. So now optical multispectral, the visible range will be mainly sensitive to the top color information of the object. So here in the case of optical multispectral, we are mainly talking about the reflection of the electromagnetic wave. Now when we are coming to the thermal region of the electromagnetic spectrum, so thermal sensors are designed to capture the thermal emission in the thermal infrared band of the electromagnetic spectrum. So here in the case of thermal remote sensing, so the emission of the electromagnetic radiation is used. Now when we are coming to the radar remote sensing, so there, since the wavelength range is long, there we are mainly going to talk about the concept of scattering of the electromagnetic wave, where a reflection will be one special case of the scattering. So now what is happening, SAR sensors or radar sensors, they are transmitting electromagnetic waves towards the Earth's surface, and when the transmitted electromagnetic pulses or bunch of the electromagnetic waves will be hitting the Earth object, so there will be scattering. Now the amount of energy which will be received back by the sensor is the back scattered portion of the signal, and that portion is used in the imaging. Now the back scattered portion of the electromagnetic wave will be sensitive to the SAR geometric parameters or SAR sensor parameters, like wavelength of the electromagnetic wave, angle of incidence, and polarization, as well as there will be sensitivity towards the structural and electrical properties of the targeted objects, like shape, size, orientation, as well as the dielectric properties of the Earth objects. So with the help of the backscattered signals, so different geo and biophysical properties are retrieved based on the scattered signal, backscattered signal. Now, when we are coming to the non-imaging microwave sensors, so generally these are the altimeters and scatterometers. They are generally the profiling devices, and they are doing the measurement in one linear dimension, because to do the imaging there will be requirement of the two-dimensional information. Now, radar altimeter is mainly used to measure the altitude information, like topography and sea surface height estimation. And when we are talking about the scatterometer, so scatterometers are used to find out the precise scattering information, and there are different applications like soil moisture estimation, as well as the sea surface roughness estimation, as well as the wind speed measurement, wind direction measurement. So these scatterometers are used in the different applications. Now, when we are coming to, because this lecture is mainly focused on synthetic aperture radar, so we are going to again coming back to the topic of synthetic aperture radar. So here you can see that there are two images shown here for the San Francisco area. So San Francisco city as well as the sea, both are clearly visible here. So synthetic aperture radar is used to create the high resolution two-dimensional as well as a three-dimensional images. Two-dimensional images will be directly captured by the sensor, and three-dimensional information will be retrieved after doing the processing in the lab. Now, what you are going to see here, like here in the optical multispectral data set, this is the true color composite image for San Francisco area. So here all the objects, they are represented in their true color, like vegetation is represented in green color, and like urban structures, they are appearing in their original color, as well as water is appearing in blue color. So we are able to see this information. Now, if you will see the top image, which is the image acquired by a synthetic aperture radar sensor. So in this image, what we are going to get, we are not going to get any color information. We are going to get only information related to the scattering. And now we are knowing that scattering is mainly sensitive to the structural and electrical properties of the targeted objects. So according to the scattering behavior, objects are appearing bright or dark, like objects like smooth surfaces. So for the smooth surfaces, what will happen? All the amount which will be transmitted by the sensor, so entire amount will be reflected away from the direction of the sensor, so that smooth surfaces, they are going to appear as dark in the SAR imagery. Now, the urban structures, they are behaving like dihedral reflectors as well as the multiple scattering, so that they are appearing as bright features. So here you can easily see, and the vegetation cover is going to appear as the moderate. It is showing the moderate brightness. Why? Because this is not going to show the low scattering, not going to show very high back scattering. Why? Because they are going to show a special kind of scattering that is known as the volumetric scattering. Because what will happen when the electromagnetic waves, when they will interact with a forestry or any vegetation, so first interaction of the electromagnetic wave will be from the top vegetation canopy. Those are mainly the tree leaves. Then the second interaction will be there from the twigs, or we can say the small branches. If the electromagnetic wave will be able to penetrate through the canopy cover, or the canopy cover density is less, so it will be able to penetrate and it will be able to interact with the small twigs. Now the third interaction will be there from the big branches. Similarly, entire volume of the structure is going to contribute in the scattering, because in the back scattered signal, in the back scattered or the received signal, there will be the scattering contributed by branches, scattering contributed by tree leaves, scattering contributed by twigs. So entire volume of the structure is going to contribute in the back scattering. So that this kind of scattering is also known as the volumetric scattering, because entire volume of this structure is contributing in the scattering process. Now we are going to have a comparison of different kind of sensors, because for Earth observation different sensors are used. So these are the sensors like LIDAR, optical multispectral, and SAR. So when we are talking about the platform, so all the remote sensing techniques like LIDAR, optical multispectral, and SAR all could be done with the help of all the type of platforms. Now when we are coming to the radiation, so LIDAR and synthetic aperture radar both are active sensors, so they will transmit their own radiation, or they will generate their own radiation, electromagnetic waves towards the Earth surface. Now, optical multispectral, this is an example of passive remote sensing, and this is completely dependent on the sun's illumination. So that if you will see that most of the optical multispectral sensors, they are not going to provide any useful information in the night time, because useful information for the Earth surface could be acquired mainly in the daytime by the optical multispectral sensors. Now, when we are coming to the spectrum, so LIDAR is generally used in the infrared range of the electromagnetic spectrum. Optical multispectral is using both means visible and infrared, because generally this reflected infrared is used to identify the vegetation information. Now, SAR is using the microwave region of the electromagnetic spectrum. When we are coming to the frequency, LIDAR is providing the single frequency data set. Optical multispectral, because from the name it is clear multispectral, so we will have the multi-frequency data set in one acquisition. Now, in the case of SAR, one SAR sensor is going to provide the single frequency data set, but multiple SAR sensors in the different frequency ranges, they can provide the multi-frequency data set. Now, there are two major advantages of SAR over LIDAR, optical multispectral, as well as over thermal also. And these are the polarimetry and interferometry. Polarimetric and interferometric phase, these phases have been used to derive a variety of bio and geophysical parameters from the SAR data set. Now, if you will go in detail, so the first concept of polarimetry and interferometry, these were derived mainly with the optical region, like in the laboratory in the like MSc physics. Generally, we did the practical of interference as well as the polarimetry in the subject of optics, particularly in the dark rooms, using the Michelson-Morley interferometer as well as the Fabry-Perot interferometer as well as the Young's double slit experiment, as well as similarly related to the polarimetry also. But those experiments were done in the strict environment, because strict environment of the dark room. Why? Because the wavelength range which is used in the visible range is very small. Wavelength is very small, and in the open atmosphere there is high possibility to get the disturbance from the atmospheric dust particle and the other wavelength ranges of the other lights. So that what will happen currently, I am not talking about the future, but currently polarimetry and interferometry concept is not possible in Earth observation with LIDAR and optical multispectral. But due to the long wavelength ranges used in the synthetic aperture radar remote sensing, like the wavelength ranges are in centimeter, like 5 centimeter, 10 centimeter, or 25 centimeter to 70 centimeter. So these wavelength ranges are not affected by the atmospheric dust particle as well as the other wavelength ranges of the light in the atmosphere. So that the polarimetry and interferometry is easily possible with synthetic aperture radar, and they have shown very high sensitivity to retrieve the different geo and biophysical parameters. Now, if you see the acquisition time, so LiDAR and SAR both could be operated in day and night, both the time periods, because this is an example of active remote sensing. Optical multispectral is mainly operated in daytime because this is passive sensor and it cannot work in the night time. Now, when you were coming to the one major advantage, because like suppose to do the flood mapping or monitoring, or for the rice crop mapping and monitoring. So generally in these time periods, entire atmosphere is covered by the cloud cover. So at that time, other sensors like LiDAR and optical multispectral sensors, they are not going to provide any information below cloud cover, because entire information of LiDAR and optical multispectral will be blocked by the top cloud cover. But in the case of synthetic aperture radar sensors, they are using long wavelength ranges, and the wavelength ranges which are used in the synthetic aperture radar is very large in comparison to the cloud particles, so they can easily penetrate to the cloud and they can provide the ground information. Now, this is the list of few famous sensors like RISAT-1. This was launched by India ISRO in 2012. Currently, RISAT-1A was launched on 14 February 2022. RadarSat is series of Canadian satellites. So RadarSat-1, RadarSat-2, and RadarSat Constellation mission. This was launched in 2019. These satellites were launched in C-band, and these are the Canadian satellites. And when we are coming to the satellites from European Space Agency, so the first satellite was launched, that was ERS-1 in C-band. This was launched in 1991. Then in continuation to ERS-1, ERS-2 was launched. They both were the tandem satellites. Those were providing the data set, tandem pair data set for different applications. Then in continuation to the SAR satellites, InviSat was launched. SAR was censored by the European Space Agency, and this was launched in 2002. Now when the InviSat stopped working, so in continuation of the C-band SAR satellite, Sentinel series of the satellites were launched. Like Sentinel-1A was launched in 2014, Sentinel-1B was launched in 2016. Now there is plan to launch Sentinel-1C, because after December 2021, we are not getting any data set from Sentinel-1B. So there is plan to launch another satellite, Sentinel-1C. So ERS, InviSat, and Sentinel series, these are the satellites from European Space Agency, ESA. Now all these satellites were in C-band. Now the GRSS was the satellite launched by Japanese Space Research Center, JAXA. This is Japanese satellite. It was launched in L-band. Now in continuation to the L-band satellite, JAXA launched the LOS series, like LOS. This was launched in 2006, and LOS-2, this was launched in 2014. So these were the satellites in L-band. Now there are the satellites in X-band also. So TerraSAR-X and Tandem-X, these are the very famous satellites. They were launched in 2007 and 2010. And these are tandems, these are providing the, basically these are the twin satellites. They are providing the identical data sets, and there are variety of applications and variety of science people are doing, not only in the image acquisition, but also in the applications also. So, these satellites are currently operational. Like you can see that after launch of 15 years also, these satellites are able to provide the data set. So these were the list of the few satellites. Now we are going to see the benefits and advantages of different bands. Out of the different satellites which we have seen that, Sentinel series, Sentinel-1A and Sentinel-1B, these data sets are freely available. So, Sentinel series data sets are widely used by the scientific community because they are providing the global coverage. Means the data set is available for the any location in the globe, as well as the repeativity. The frequency to acquire the data set repeativity is also very good. So after 6 days or 12 days interval, we will have the data set for the same area. So the people are able to do the continuous mapping and monitoring of the earth surface for the different application, like for the glaciological application, or for the crop mapping and monitoring, or for the soil moisture estimation. So there are different applications. We will be going through a few of the applications also. Now, when we are coming to the P band, so a P band planned wavelength range is approximately 70 centimeter. And like currently, we do not have any operational space-borne SAR satellite in P band. So first satellite which will be launched will be the biomass. So this satellite will have the high penetration because 70 centimeter wavelength range is there, and it will be able to provide, it will be able to penetrate through the canopy cover of the tropical forest or the broadleaf forest area also, and it will be able to provide the information of entire forest structure, so that one will have very good information of forest above ground woody biomass. So the sensor name they have given the biomass, and this is dedicated to the biomass retrieval of the forest parameters. But these data sets could also be used for the other applications, because since wavelength range is very large, so even it will be able to penetrate through the land surface also. And it will be able to provide the information of buried objects, which could be used for the archaeological applications. And it can also be used to map the forest disturbances. Now, there are several challenges in the P-band SAR. Several challenges. Why? Because there is when the electromagnetic waves are transmitted in the microwave range, so generally it is assumed that there will not be any effect due to the atmosphere, because these wavelength ranges are large. But here there will be some effect due to the ionosphere, as well as the troposphere also. But mainly we are talking about ionosphere, because particularly in P band, the energy will become very less. Energy of the electromagnetic wave will become very less, because wavelength is large and frequency will become small. And when the small frequency will be there, energy will also become small, so that what will happen? There will be very high attenuation in the ionosphere, because ionosphere is having highly charged ions. So when this P band will propagate, there will be high attenuation. Now, this challenge was taken by the European scientists, and finally they have prepared this sensor. And I think in 2023, this sensor will be launched. Now, when we are coming to the L band, so there are several satellites. Like CSAT was the first sensor which was launched launched to acquire the data set with the help of the synthetic aperture radar. And this sensor was launched in L band, and here you can see that there are several sensors like GRSS, ELOS, SAOCOM, and NISR-L and TANDEM-L. Like NISR-L and TANDEM-L, these are the future SAR missions. This will have the good penetration capability. This could be used for the forestry, environmental mapping and monitoring, agricultural, as well as different other applications. Now, when we are coming to the S band, so generally 10 to 12 centimeter wavelength is used. So there are less sensor in comparison to the L and C band. So we can see that LMAS, SJ, Condor, NOVASAR, and one future mission like this is NISR. So this sensor has shown their utility in the ship detection, ice mapping, oil spill detection, flood mapping and monitoring, crop classification. So they have shown good sensitivity to retrieve these parameters. Now, when we are coming to the C band, so C band has also been widely used for the crop parameter retrieval as the classification of land use and land cover. The mean wavelength range which is used is 5.4 to 5.7 centimeter wavelength range. And a variety of sensors are there, like ERS 1 and 2, InVSAT SR, Radar Set 1, 2, RCM, RISAT 1 and 1A, Sentinel 1AP, and now Sentinel 1C will also be launched. So these have been sensitivity for the shown sensitivity for the crop parameters retrieval, ocean features, ship detection, the sea ice surveillance, oil spill mapping and monitoring. Now when we are going to see the X band, so generally 3 centimeter wavelength range is used. So there are again several sensors: TerraSAR-X, Tandem-X, Cosmo SkyMed, TechSAR, RISAT-2, PAJ, ComSat-5, and ICI Constellation. So in this, there are the missions from the space agencies, as well as there are several missions from the private agencies also. So this has, since the wavelength is small, so they will have very high sensitivity towards the surface roughness, and it will have the high resolution applications as well as the topographic mapping and monitoring, including the flood mapping also. Now this is the Indian SAR Earth Observation Satellite. So RISAT-2, here you can see that RISAT-2, this was launched on April 20, 2009 X-band. RISAT-1, this was launched in April 26, 2012. In C-band, this was the first satellite in C-band launched by ISRO for Earth observation, and this was the first sensor, particularly in the hybrid polarimetry, because most of the Earth observation sensors, they are launched either a single, dual, or quad pole capability. RISAT was having the capability to acquire the data set in hybrid pole, and RISAT-1A, which was launched on February 14, 2022, it is having the unique features. It can acquire the data set in hybrid polarimetry as well as the fully polarimetry also. Similarly, RISAT-2B was launched in 2019, 2B and 2BR1, and the future mission is NASA ISRO Synthetic Aperture Radar mission. And this is the prestigious mission, and not only these two space agencies, entire world is looking for this mission, because this mission will be the most advanced mission in the terms of technology, in the terms of hardware design, in the terms of the data processing also. And this will be the first mission for the Earth observation, which is going to provide the data set in dual frequency in L band and S band. Because most of the spaceborne SAR missions, if you will see, they or all the spaceborne SAR missions, they are providing the data set in one frequency range only, and NISR will be the first mission which is going to provide the data set in 2 frequency ranges. Now we are going to quickly understand the need of SAR data set. So the first image is the list for false color composite image for Dehradun area. Dehradun as well as the Doon Valley forest. So here we are going to see that since this is false color composite image, so in false color composite image, the vegetation is represented in red color, because infrared channel is represented, infrared channel is given to red color, so that in infrared vegetation will have very high reflectance. So entire vegetation will be represented in the red color. And here you can see that from the variation in the shades of the red color, one will be able to identify the different types of the vegetation, like crops are appearing in the pink color. Similarly, like the bushes as well as the kind of the old trees and like a high canopy density, those could also be seen. Now, if you will see the RISAT-1 based hybrid pole based FCC false color composite image. So again, like here we are able to see the different features because vegetation is represented in green color, urban area is represented in red or pink color, and water body is represented in blue color. Now here we can see that when we are comparing of SAR data set with optical multispectral, so optical multispectral is going to appear very well because our eyes are working very well in the visible range of the electromagnetic spectrum, because our eyes are mainly working with the visible range, and this data set is acquired in the visual range. So for the visualization purpose, optical multispectral data set is going to appear very good. But SAR data set is not only used for the visualization, this is used to retrieve the different information. Now this one scene is of approximately of 25 kilometer by 25 kilometer area. So that what I'm going to do, I'm going to show the zoomed view of the different locations within this study area or within the image. Now I'm going to show the one band of the LIS4 and one polarization or the polarimetric band of the RISAT-1. Now, here, as we are knowing that optical multispectral is mainly sensitive to the top color information of the object. Now, just focus on the encircled area, red circled area. So, red circled area is basically the area of the Pashu Lok barrage. Now, here in the optical multispectral data, you can see that color information or the color of the barrage is merged with the background water, so that we are not able to get any information of the barrage. Barrage is there, but the color information of the barrage is mixed with the background water, so the sensor is not able to distinguish these two features. Now, when we are coming to the RI set 1 data set, one polarization of RI set 1 data set, so we are knowing that SAR data set is not sensitive to the color information. Microwaves are not sensitive to the color information. They are mainly sensitive to the structural and electrical properties of the targeted object. So structural and electrical properties of the barrage will be entirely different than the background water. So that what we are going to see, we are going to clearly detect the barrage here as a separate feature. Okay. Now, in the next slide, we are again going to see for the another area of the image. So there is another barrage. This is Bhimgowda barrage in Haridwar. So again, this barrage is not visible in the optical multispectral data set. Region is same because color information of the barrage is mixed with the background water. Now, since the barrage, structural property of barrage that will be made of like iron bars and concrete materials. So that is entirely different than the background water, because background water structural property will be very smooth surface. So this is able to detect that separate feature because very high scattering is received from the barrage. Not only this big one, this small structure which is used to divert the water could also be detected. Now, other sensitivity we are going to talk about. First, we have seen that sensitivity towards the structural and the electrical property. So there we got the advantage. Now, other advantage we are going to discuss here, that is shown here in the blocks of the yellow color. That is the sensitivity towards the terrain topography. So now if you see the terrain topography, so in the optical multispectral data set, some sensitivity is there and we are going to get some information. But just see the SAR data set for the same area, we are going to have very high sensitivity towards the terrain topography, because here you can see that these are the dry river channels and undulation in the terrain and the topographic variation. And all the information, all the structural information of the terrain could be easily seen. And this information is completely missing in the optical multispectral data set. So generally, to retrieve the structural property of the surface, SAR data sets are used. And these data sets have also been widely used to generate the digital elevation model of the Earth's surface. Now here, if you will see for the another region, so in this area also, if you will see, so here you are going to get that the clear variation in the topographic terrain, and the optical multispectral data set is showing less sensitivity. Now, two advantages we have seen. One is the sensitivity towards the structural and the electrical properties of the targeted object, and sensitivity towards the terrain topography that is related to again the structural property. Now, another advantage we are going to talk of the SAR data set, that is related to the soil penetration capability. So the penetration capability we are going to see, like this area, just focus on the middle strip. This is the area of the Sahara Desert. So in the Sahara Desert area, what we are going to see that the optical multispectral data set is going to show the golden color information of the sand. Now, when the electromagnetic waves were transmitted by the SAR mission, that is the shuttle imaging radar A. So this was having L-band sensor. L-band will have the approximately 23 to 24 centimeter wavelength range, very large in comparison to the optical multispectral. And the area is very, very dry, because when the area is dry, penetration will be very high. When the moisture will be there, due to moisture, penetration will become less, because dielectric property of the surface will be increased. So what will happen? So when the area is dry, so it is able to penetrate and it is able to interact with the subsurface structure. Now, if you will see the subsurface structure, so this is clearly showing the presence of paleo channels. So the paleo channels are detected, which are buried or which are in the subsurface of the Sahara Desert. So like this is giving a lot of information in the sense like currently there is desert, and if paleo channels are there, it means that in past several thousand years ago, the Sahara was not a desert, because when paleo channel is there, if channel is there, it means that it might be possible that there will be water body, and when water body is there, so it might be possible that the in past several thousand years ago, this area was not a desert, greenies were also there. Now, another property which we are going to talk, that is the cloud penetration capability of the SAR sensor. So, like this is the area near to Varanasi, the Varanasi city. This is appearing in the cyan color here. This is the Sentinel-2B multi-spectral instrument dataset. This is the standard false color composite image from the Sentinel-2B. So here you can see that these are the agriculture belts, and like crops could be easily seen here. And this was the image of 15th January to 24th February 2021. So here at that time no cloud cover was there, so that we are able to see the clear information of the Earth objects. But on 15th January 2021, this area was entirely covered by the cloud cover. Again, this is Sentinel-2B false color composite image. So due to the cloud cover for the same area, we are not able to get any information of the Earth's surface. And for the same date, Sentinel-1A datasets were available. The right-hand side image is of VH channel, and the left-hand side image is of VV channel. So here what we are going to get, we are going to get the clear information of the Earth object, like the presence of the holy river Ganga that could be easily seen here. Okay, and like Varanasi city is also appearing in the bright color here. And one more thing we can see that, like in VV and VH, if you will see, in VV it is easy to identify the urban features, but in VH it is not easy to identify the urban features, because the objects are not clearly visible. So one can easily say that the polarization VV is having high sensitivity for the urban structure information retrieval in comparison to the VH. Now this is animation made by European Space Agency. So I am just going to show how SAR sensor is working. SAR sensor is transmitting electromagnetic pulses towards the Earth surface. And here you can see that it is able to penetrate to the cloud cover, and it is able to provide the information of the Earth object based on the back scattered information. Like here you can see the urban settlements, they are appearing in the bright color, water is appearing in dark color. Similarly, all the features, they will be appearing according to their back scatter properties. Now briefly, we are going to talk about the SAR geometry, because when we are processing the SAR data set, there is a requirement to know the parameters, particularly information about the resolution as well as the angle of incidence, because this is used to measure the back scatter cross section. Now, if you will see here, so there are basically two directions. The direction in which synthetic aperture radar sensor is moving, that direction is known as the azimuth direction. And the direction in which SAR sensor is transmitting electromagnetic pulses, that direction is known as the look direction. So now all the synthetic aperture radar sensors, they are the side-looking radar sensors. The vertical direction of the sensor is known as the nadi direction. But SAR sensors are not the nadi looking, or not transmitting the electromagnetic pulses in the vertical directions. All the SAR sensors are the side-looking radar sensors. They are making some angle, look angle, and they are transmitting the electromagnetic pulses. These look angles are decided before doing the data acquisition. Now, if you will see, when the angle of incidence is the angle between the incident electromagnetic wave and a perpendicular or a normal drawn to the point of incidence. So the angle between that normal and the incident electromagnetic wave will be the angle of incidence. Now, the entire image will be generated from near to far range. There are two ranges, because the illuminated area, when the electromagnetic waves will be transmitted by the sensor, one area will be illuminated. The portion of the illuminated area which is near to the nadir will be known as near range, and the farthest point from the nadir will be known as the far range. So once our image will be generated from near to far range. Now when you will move from near to far range, the angle of incidence will also vary. So that here you can see that angle of incidence in near and far ranges are represented by N and F, like theta N and theta F. Okay, and there are different other parameters, but we are not going in very much detail. Now, since we are knowing that there are two resolutions, there are two directions, azimuth directions and range direction. Now, due to these two directions, there will be two resolutions in single SAR resolution cell, because in all the other data sets, if you see optical multispectral or any other data set, so there will be only one resolution. Resolution is the capability of the sensor to distinguish two closely spaced objects. Now, azimuth resolution is the capability of the sensor to detect the two closely spaced objects in the azimuth direction, and range resolution is the capability of the sensor to distinguish two closely spaced objects in the range direction. Okay, so if in this diagram we are going to see, suppose this square pixel is representing resolution cell. So here you can see the length of resolution cell in azimuth direction. This is the direction of flight. Here you can see that will be the azimuth resolution, and this will be the range resolution, the length of resolution cell in the range direction, or the direction in which SAR sensor is transmitting the electromagnetic pulses. Now, the concept of synthetic aperture radar also we are going to understand with this slide. Like, what will happen? The real aperture radar, if you will see that the real aperture antenna length is represented by a small LA. Now, when this will be small LA, so here you can see that azimuth resolution is directly depending on the length of the antenna. When the antenna length is very, very small, so what will happen? The resolution will not be very high. It will be of several kilometers in the case of spacebound SAR remote sensing. But to do a clear visualization or the information retrieval, we need a high resolution like 5 meter, 10 meter, or 1 meter resolution. So at that time, a synthetic or virtual antenna is created with the help of the real aperture as well as the velocity of the aircraft or spacecraft. So synthetic aperture in SAR remote sensing, a synthetic aperture is created by utilizing the velocity of the aircraft. So here one can see that, one can understand that. Like, suppose this is the real aperture position. Suppose this is moving in forward direction or in azimuth direction. Suppose this is the first point. From there, it is able to track a point target. It is able to get information of the object. Suppose what we can understand like that. Suppose the data set is required for a city, and this pixel is representing a building. So this building was not detected before this point because SAR sensor, this was not coming in the visibility range of the sensor. Suppose this is the first point. From there, SAR sensor will transmit the electromagnetic pulses, and after scattering, it is able to get the back scatter signal from this point target. So what will happen? The sensor will able to get this information, and again sensor is moving, transmitting the electromagnetic pulses, and what will happen? And this is the midpoint. From there, the distance, range distance between target to sensor will be minimum. Again, from here also it will get the information. So continuously, it is moving, transmitting the electromagnetic pulses and receiving. And suppose this is the last point. Beyond that, this point target will not be coming in the visibility range of the sensor. So what will happen? Sensor is having the continuous information because it is transmitting the electromagnetic pulses, continuous information of this point target from this point to the end point, or you can say the first point to the end point. So what will happen when you will see that the entire information, when you will merge all the signals from this point to this point, back scattered signal from this point to this point. So entire distance traveled by the SAR sensor to get the back scattered signal of this point target will behave like a virtual antenna. Actual antenna is large, but total distance which is used to get the back scatter signal of this point target will become very large. So all the signals are merged, so that what will happen? The entire distance traveled by synthetic aperture radar sensor will be behaving like a synthetic aperture, and here this will become of the several kilometers. synthetic aperture length may be of several kilometers. And now here you can see that when this distance will be of several kilometers, so the azimuth resolution will become of few meters, like 5 meter, 10 meter, or 1 meter. So the synthetic aperture synthetic aperture radar technique is mainly used to get the high spatial resolution data set, particularly in the azimuth direction. Now there is another resolution, that is the range resolution. So range resolution is not directly depending on the antenna length. This is depending on the pulse width. So that is represented by tau. So C tau divided by 2. Now here we can see that the objects are detected in the range direction. So here you can see that electromagnetic pulses are transmitted, and suppose the pulse width is 1 microsecond. So for 1 microsecond, what will happen? When you multiply with the speed of light, this will become 300 meter. And according to the formula, the range resolution will be C tau divided by 2. It means that all the objects which are separated by a distance 150 meter, means 300 divided by 2, that will be 150 meter. So if they are greater than 150 meter, so both will be identified as two separate objects. If they are less than the distance, or if their size is less than the 150 meter, so they will be identified as a single object. So here you can see that when the pulses are transmitted in the range direction, so what will happen? The distance between the aircraft is 100 meter only. So in the return signal, here you can see that only a long pulse is received by the sensor. It means that both objects will be merged and they will be placed in single resolution cell. The sensor will not be able to detect these two objects as two separate features. But in the case of the bottom case, here if you will see, the distance between the two targets is approximately 200 meter, and this is greater than 150 meter. And here you can see that SAR sensor is able to detect two separate responses from these two features, so that both the objects will be identified as two different objects in the SAR imagery. Now, when we are talking about the synthetic aperture radar remote sensing, so polarized electromagnetic waves are used. Basically, we are talking about the polarization of the electric field vector, because in electromagnetic field, there will be electric field vector, there will be magnetic field vector, and there will be one direction of propagation of electromagnetic wave. Electric and magnetic both will be perpendicular to each other and mutually perpendicular to the direction of propagation of the electromagnetic wave. So what will happen? The unpolarized energy will vibrate in all the possible direction perpendicular to the direction of travel. So at that time, what will happen in the return signal after scattering, again the energy will be unpolarized. So the image will become noisy, and finally the clear imaging will not be possible. So the radar antenna send and receive the polarized electromagnetic signal, and these polarizations are done either in the vertical direction or horizontal direction. So here you can see that here the polarimetric combinations are given here. When the electromagnetic waves will be transmitted vertically, so that will be known as the vertical polarization. And again, if after scattering, again the vertical polarized electromagnetic waves are received, so that combination will become VV. It means that vertically polarized were transmitted and vertically polarized were received. Now, in the case of horizontally polarized, here you can see that horizontally polarized electromagnetic waves were transmitted and horizontally polarized were received. So what will happen? This polarization will be known as HH. So when we are coming to HV, in HV, horizontally polarized electromagnetic waves will be transmitted, and after scattering, vertically polarized will be received by the sensor. Similarly, in the case of VH, vertically polarized will be transmitted and horizontally polarized will be received. So what will happen? We will have the maximum 4 polarimetric combinations. If it's like these are the linear polarimetric combination, linearly polarized data set. So what will happen when the SAR sensor is capable to provide any one polarimetric combination out of these four polarizations? Then that data set will be known as single polarized data set. Any polarization like HH, HV, VH, or VV. The data set will be known as single polarized SAR data. If the SAR sensor is capable to provide the 2 polarimetric combinations out of the 4, then that will be known as the dual polarimetric SAR data set. If the SAR sensor is capable to provide all the 4 polarimetric combinations at the same time for the same area, then that data set is known as quad pole fully polarimetric SAR data. Now here we are going to understand about the imaging by SAR sensor. So SAR sensor is transmitting the horizontally polarized electromagnetic waves, and when the bunch of electromagnetic wave will interact with the object, so again there is possibility that in the scattered signal, some portion of the scattered electromagnetic wave will start vibrating in the vertical direction, but since the transmitted or incident polarization was horizontal, so most of the energy will be in the horizontal polarization only, but some will start vibrating in vertical as well as some will be unpolarized. At the time of receiving, when the sensor is receiving the horizontal polarization, then the combination will become HH, and it will be receiving vertical polarization, then that combination will be known as HV. So here you can see that from same transmitted edge, there are 2 images or 2 polarimetric combinations could be generated. One will be HH and another will be HV. Similarly, in the case of vertical also, single vertical will be transmitted, and after scattering, vertical and horizontal will be received, so that the combination will become VV and VH. Now this is SAR data set for the Visakhapatnam Fort report. This data set is freely available. This is high resolution data set of TerraSAR-X, approximately I think 50 centimeter resolution. So here you can see that the ships and the buildings as well as the trees, these are clearly visible in the image, and they are they are appearing in the bright and dark according to their backscatter behavior. Ships could also be clearly detected. And here you can see the plain ground as well as roads, they are appearing as dark surface. Why? Because when the electromagnetic waves are transmitted, entire amount will be reflected away from the direction of the sensor. So very less scattered information will be received by the sensor, so that these type of objects like water, playground as well as the roads, they are going to appear as the dark features. Now the surface roughness is very important when we are talking about remote sensing. So surface roughness is mainly depending on the wavelength, depression angle and the local height of the object. I would like to quickly show you one example, like these are the Peaks and Olivers modified delicate area. Like for the aircraft Ka band and CSAT L band, you can see that the combinations are given. Wavelength is 0.86, gamma is 45 degree, and for CSAT L band, this was wavelength was 23.5 centimeter, depression angle was 70 degree. So here you can see that all the surfaces which will be having object height greater than 0.276 centimeter is going to appear as rough surface. Now the surface which is behaving like, suppose the object height is 0.5 centimeter. So the surface which is going to appear as rough surface for aircraft Ka band is going to appear as a smooth surface for CSAT L band, because with this configuration, all the objects which will be having, all the surfaces which will be having object height less than 1 centimeter is going to behave like a smooth surface. Now here we are going to talk about the interaction of electromagnetic wave with soil. So when the soil will be dry, in the case of dry soil, very high penetration will be there, less scattering will be there. So what will happen? Those features are going to appear as dark features, because less back scattering will occur and less amount will be received by the sensor. Now in the case of wet soil, moisture content is there, that is increasing the surface roughness as well as it is increasing the dielectric property, electrical property will be increased. So what will happen? Less penetration will be there, and high back scattering will be there, and high back scatter information will be received by the sensor. Now in the case of flooded soil, when the surface will become perfectly smooth, SAR sensor will transmit the electromagnetic pulses and it will be reflected away from the direction of the sensor. So here what we are going to see, the dry soil is going to appear dark, relatively darker than the wet soil. Wet soil is going to appear brighter than the dry soil. But in the case of flooded soil, the flooded area is going to appear as very, very dark, because there will be perfectly there will be perfect reflection from the surface. Now we are going to talk about the response from the pine forest. So here you can see that L band is having long wavelength ranges. It will have the more penetration capability. It will be able to, so in the received signal, it will have the more structural information from the different components of the forest. In C band, wavelength is 5.8 centimeter. So there will be less sub features information in comparison, less structure information in comparison to the L band. In X band, there will be mainly information from the forest canopy. Now, since SAR data set is used mainly to retrieve the phase and amplitude information, so each and every resolution cell, or you can understand with a pixel, each and every resolution cell of the SAR data set will be represented by complex number, one real channel information or real value, and another will be the imaginary channel information. So each SAR data set will be represented by the complex numbers, real channel as well as the imaginary channel, because with the help of that one will be able to find out the amplitude as well as the phase of the electromagnetic wave at the time of interaction with the target. So phase and amplitude both could be retrieved from the complex SAR data set. So to do the polarimetry or interferometry, if you are working, there is a requirement to order the data set in complex mode. Now we are going to get the speckle also. Speckle is the mainly coming due to the interference of the incoming signals. So here you can see that like for the TerraSAR-X and TerraSAR-X for the Visakhapatnam area, like here we are knowing that in this water body that there will be like a smooth surface is smooth, so they should appear dark. But here, due to the speckle effect, due to the interference of the return signal, now the return will be very small, but due to this interference, we are going to get the speckle noise. Now there are speckle filters. These are the low pass filters, so the speckle noise could be easily removed. And here we are able to radiometrically enhance the data set. Now the SAR data set is acquired in different modes: strip map mode, spotlight mode, ScanSAR mode. Strip map mode, moderate resolution, moderate swath. Spotlight mode, very high spatial resolution, up to 25 centimeter resolution could be generated. ScanSAR mode, very large swath, like 250 kilometer, 300 kilometer by 300 kilometer swath will be there, but a resolution will become coarse. Now there are several data formats like raw data, SLC data, multi-loop data, geocoded data, polarimetric data. So generally for doing science, we are preferring to use the SLC data set, because raw data will be simply a collection of the response of the electromagnetic signals received after backscattering by the objects. So in that it will not be possible to do the visualization. There is a requirement to compress those signals. Now after compression, single loop complex image, this complex image will be generated, and from this complex image the multi-loop data set and geocoded data set could also be derived. Now polarimetric data set, as we have already talked about, like single polarized, dual polarized, as well as the quad pole fully polarimetric SAR data set. Now these are the advanced technique of synthetic aperture radar remote sensing: polarimetric SAR, interferometric SAR, and the advantage in interferometric SAR are small baseline subset and the persistent scatterer. Polarimetric SAR interferometry is the utilization of polarimetry and interferometry. These two techniques, these have been widely used for the forest parameter retrieval. SAR tomography, this has also been used mainly for the forest parameter as well as the urban structure information retrieval, 3D view of these features. And interferometry has been widely used to retrieve the elevation as well as the subsidence information retrieval. So when we are talking about the polarimetry, so there we are going to use all the four polarimetric combinations like HH, HV, VH, and VV. So this is the advantage of polarimetry. Like suppose that there is a different kind of features in a small area or in a single pixel, suppose 10 meter by 10 meter resolution cell. Suppose there are different kind of objects like a smooth surface, then double bounce scatterer, as well as the volumetric scatterer. So this will be possible to understand with the help of the fully polarimetric data set by implementing the concept of interaction of electromagnetic wave with different kind of features: interaction of electromagnetic wave with surface scatterer, interaction of electromagnetic wave with double bounce scatterers for randomly oriented dipole. One will be able to retrieve how much contribution in scattering is contributed by this smooth surface in that pixel, how much scattering is contributed by double bounce scattering, and how much scattering is contributed by this volume scattering. So polarimetric data set gives the flexibility to implement the modeling approaches of the interaction of the electromagnetic wave with different kind of features to retrieve the reliable and exact scattering information from the SAR data set within a resolution cell. Now, when we are coming to the interferometric SAR, so interferometric SAR data set, this is the simplest example of we can understand with the Young's double slit experiment. Like the data set will be acquired from the two different locations, And by maintaining a distance, that distance is known as the baseline, and data set will be acquired, and that data set will have sensitivity towards the height, elevation, as well as the subsidence. Now, the SAR interferometric phase is mainly used to find out the elevation and the subsidence information or the change. And the differential SAR interferometry is used to find out the change in the surface up to 1 centimeter. This technique was first discovered by the Gabriel et al. In 1989. Now there are advanced techniques like persistent scatter interferometry and SBAS. In these techniques, large number of scenes are required so that the subsidence could be measured in millimeters. So I have given the references. One can go to the references of the slides so that they will be able to find out the detailed information. Now there is another technique, polarimetric SAR interferometry. In this, the quad pole data set, fully polarimetric data sets are acquired in interferometry, so that this will have the capability to find out the vegetation parameters, particularly vegetation height. So when we are talking about the in-SAR phase and the pole in-SAR coherence, in SAR interferometry, mainly we are talking about the interferometric phase. But in the case of pole in-SAR, we are talking about the coherence information for the inversion modeling to retrieve the forest parameters. There is one very advanced technique, that is the SAR tomographic. This is used to generate like two-dimensional information will be there from the SAR data set, but from the tomographic approach, there will be possibility to create the vertical resolution. So this vertical resolution is created to find out the height information as well as the scattering contributed by the different height level. Now these are the satellites which are having the capability to provide the pole in-SAR data sets. Like these are the TerraSAR-X and TandemX twin satellite. If TerraSAR-X and TandemX both will be working individually, so the data set, the interferometric pole in-SAR data set will be available after 12 days, because satellite will come to the same location after 12 days by maintaining a baseline, and it will require the data set. Now in the case of LOS2 Pulsar 2, it was launched in 2014. The interferometry is not possible with the less than the 14 days. So like the pole in-SAR data set will have the minimum gap of the 14 days. Radar set 2, it will have the 24 days repeat cycle. So interferometric data set could be acquired for every cycle of the 24 days. Now these are the future satellites like NISAR, NASA Isosynthetic Aperture Radar Satellite, that will be L and S band. This will have the 12 days repeat pass, and this data set will be freely available to all the users. This will be launched in 2024. ESA P-band Synthetic Aperture Radar Biomass Mission. This will be launched in 2023. This will have the 17 days repeat pass. And the Tandem L, this will be launched most probably in 2024 or after that also. But this will be the L-band data set that will be launched by the DLR, Germany, and we will have the L-band tandem data set. Now there are different applications of SAR remote sensing, SAR interferometry for DM generation, for subsidence mapping, for cryospheric or the glaciological application, for soil moisture estimation, for biophysical parameter retrieval, for crop mapping and monitoring, flood control, and oil spill detection. Quickly we will be going to see. Like for the forest parameter retrievals, so polarimetry and interferometry, both the techniques are used. So in the scattering from the forestry, what will happen? The interaction of the SAR will be there from the forest ground as well as from the vegetation also. There will be interaction from ground to trunk also. There will be like one-way attenuation, like it will be interacting with the ground, and in the return signal, that electromagnetic signal will be attenuated by the vegetation canopy, and it might be possible that there will be two attenuation also. So fully polarimetric SAR data set gives the flexibility to retrieve these components. Now this is another forest area like Haldwani forest area. So in this forest area, what you are going to see that here you are able to see that the different age group of the plantations, they could also be retrieved from the SAR data set. Now this is the Dudhwa National Park, and this is dense forest area. And here the different forest types you can see here, which are imaged with the help of the synthetic aperture radar sensor. This is the LOS Pulsar data set. Now here I'm going to show one study which is carried in IIRS for the pole in-SAR for the forest height retrieval. So I and my group, they did this study. So here we modified the algorithm which was given by the scientist of the European Space Agency. Because when the same algorithm was implemented on the spaceborne SAR dataset, because those algorithms were mainly developed for the airborne SAR dataset. But when we implemented for the spaceborne SAR dataset, so what we found that there was false vegetation height information. So we improved that algorithm, and we proposed a new algorithm by including the pollens, the coherence as well as the backscatter information. And here we can easily see that for the dry river channels as a water body and as well as the urban structure, there is no forest height. And finally, we got the very good forest height information with the help of the pole insert channel. And here you can see that the accuracy was approximately 94.07, and the detailed information of the methodology you can get in this publication. Now we again tested the multi-frequency pole insert data set for the forest height retrieval using C-band, X-band, and L-band data set. So these were compared with the GTI forest height map also. So we received a very good forest height information. And this literature is freely available because this is open access journal. So you can get this information, the detailed information is published, and you can get the detailed information of the methodology as well as the data information. But this data set, RadarSat 2, TerraSAR-X, and Elasto Pulsar 2 are not freely available. Now here it is forest height. We have seen that with the help of pole insert. Now this is related to above ground biomass estimation. So here we developed a model. That model is named as extended water cloud model. Actually, water cloud model was mainly developed by Atemanu Levy in 1978. Then again modified by Dr. Askene and Santoro to retrieve the forest parameter retrieval. And now we extended it by adding few parameters, as well as by implementing the fully polarimetric SAR data set. So this shows the less dependency, because earlier there was very high dependency on the field data set to calibrate the model parameters. So we tested in two phases, one with very with less parameters to calibrate the model parameters, less field data, and then without field data also we tested, and we found that the reliable accuracy R square was 0.78, and though the RMSE is not very low, but without including the field data or with very less field implementing field data set, this is also very good. And we tested it for approximately more than 150 plots of the field data set. We tested it. Now this is SAR tomography, like Fourier, Capon, and beam format tomography. These were the signal compression technique we implemented for the SAR data set. So that what happened here, we found that this has shown very good capability to find out the forest height information. Out of Fourier beam format Capon show a very good sensitivity to retrieve the forest height. And this article is also available in IEEE JSTARS. One can go in detail. Now another is based on the UAV SAR. So in UAV SAR here we can see that this is the part of the AFRI SAR mission. These data sets are freely available, like the SAR data sets which were acquired. Large number of SAR data sets were required to create the vertical resolution. So those data sets are also available. And the field data set as well as the LIDAR data set for the canopy height is also available. So with the help of that, we implemented the modeling approach for the Gabon forest area. And we got a very good accuracy in the forest height retrieval. And here you can see that very good interesting result we are getting. Like when the water body is there, so we are getting the zero height, and as soon as the vegetation come in picture, so here we are going to get the vegetation height. Okay, so this information is retrieved. Now we implemented the pole in SAR and pole SAR based modeling in the random forest machine learning algorithm to retrieve the forest biomass area for the Malhan forest range of Dehradun. So very good accuracy was achieved in the forest above ground biomass retrieval. Now SAR dataset has also been used for the soil moisture retrieval. So this is the global map of the radar cross section, which was taken from the SMAP mission of the NASA JPL. So here you can see that it is showing the high sensitivity toward the moisture content, because just see the Himalayan region as well as the region of coastal region. So there we are going to get the high moisture due to vegetation as well as due to the soil moisture. So all the area which will be having high moisture content, they are having the high scattering, and the areas near to Rajasthan and Gujarat, here you can see that there will be less back scattering near to -25 to -20, so that soil moisture could be easily estimated. We carried this study in collaboration with IISR Bhopal. So here you can see that soil moisture map was generated with the help of Sentinel-1 dataset. And when this was validated with the field dataset which was collected during the field survey, so very good accuracy was achieved. So this soil moisture technique is also available. And suppose if one wants to go in detail of the SAR tomography, so again I will suggest you to go with the paper written by us in that is why I am showing this, because this is again open access journal, that is of Journal of American Geophysical Union, AGU, coming under the Ville publication. Journal is Earth and Space Science, so you can go in detail of that. And this soil moisture map technique is available in this journal. Remote sensing article is available. You can go in in detail of other things. So crop parameters and crop mapping and monitoring is also easy, because one study was carried in IIRS by Dr. Mamta Kumari. So here you can see that with the help of the polarimetric SAR dataset, it is possible to even distinguish the two different types of the same species, like basmati and non-basmati. These are the rice crop only. So these paddy crops could be, these two species of the paddy crop could be easily distinguished with the help of the fully polarimetric SAR dataset. Why? Because their phenological stages are different. Due to the different phenological stages, there will be difference in the scattering, and that difference in the scattering could be easily identified with the help of the SAR dataset to do the mapping and monitoring of these locations. Now, SAR dataset has been used for the DM generation. So here I am going to show you mainly the SAR interferometry based, because SAR interferometry and stereo SAR both could be used. So here I am going to show you the SAR interferometry. So this sample dataset for the Fujiyama mountain of LOS one pulsar 1 dataset for Fujiyama mountain was acquired. And here you can see that the area where there is less change in the height or elevation. So fringes are interferometric fringes are very flat. And when there is high change in the elevation or sudden change, so there are closed fringes, or you can say narrow spaced fringes, closely spaced fringes are there. So there will be high sensitivity towards height, and when this was converted to height, so here you can see that this is the 3D view of the Fujiyama mountain, which was retrieved from the LOS pulsar dataset. Now, SAR dataset has also been widely used in human settlement, land subsidence, and the altitude measurement. So here, this is a study which is carried to find out the land subsidence. Large number of datasets were acquired to, and PS-INSAR was implemented. This study was carried by, I think, the scientists from US. So for Los Angeles, the subsidence were detected due to the tunnel that was created for the metro construction. So underground construction was there. So due to that underground construction, there was subsidence on the surface that was detected. Now another subsidence was detected with the help of the TerraSAR-X dataset for the Barcelona area. So that subsidence or movement, ground movement was measured. This was approximately -10 millimeter per year. Now, we also did one study related to the Bergen oil field. So in Bergen oil field, they implemented PS-INSAR technique with the help of more than 26 scenes of the TerraSAR-X dataset for the 3 years time period. So these datasets were acquired, and finally, PS-INSAR technique was implemented, and we found that approximately 10 millimeter subsidence was there, and all the other detail you can go through this publication. Now, this is the study carried by the DRR scientists to generate the 3D view of the Berlin city. So here you can see the view of the Berlin city, height information, as well as all the other view is generated, and one can find out the reliable information related to the settlement. And it is also possible to generate the high resolution view from for the individual buildings also. Here you can see that very good information of height is retrieved from the SAR tomography technique. Now, SAR remote sensing has also been used for the archaeological mapping and monitoring. In a few more minutes, I will complete my lecture. Now, one study is carried for the cultural heritage site of the Angkor Wat, because Angkor Wat was built by the Khmer king Suryavarman II during 1113 to 1149. And this temple gives several pieces of cultural information, including the details of 4 major time periods of Hindu cosmology. So this is a UNESCO World Heritage Site, and not only like only a normal site. This is most studied site of the UNESCO, because the people from astronomy and astrophysics, they also did this study. People from geology, people from archaeology, they all have done a study, because this structure is very old. And like one wall of this temple is mainly dedicated to the Lord Vishnu, and the largest religious place in the world. One side of the temple is having the sculptures of the Ramayana, another side is having Mahabharata. I am not knowing the exact site, but exact location, but like on the walls of the sculptures are there. Similarly, like this has a lot of cultural heritage information. So that like due to the increased tourism, or if there will be any change in the groundwater table, so due to that change, there may be land subsidence, and if there will be land subsidence, so if any structure is very old, so if land subsidence will occur, that structure may be collapsed. So several studies were carried out to find out the land subsidence. So we also did this study with the help of the ELOS Pulsar data set of the 2 time periods, now extended with the Sentinel one also. We did not get any subsidence. Here this is the PS-INSAR technique, and finally we found that there is no subsidence. It means that this structure is free from any damage from the land subsidence. Now the similar kind of study was also carried for the other locations, like this is a study carried by the Chinese scientists for the Summer Palace in China. SAR and GPR both have been widely used to find out the subsurface information. Here, with the help of the ground penetrating radar, one will be able to find out the information of the subsurface. And P-band SAR sensor, here you can see that SETI one will be able to find out the subsurface information. Here you can see the paleo channels are clearly retrieved from the SAR dataset. Now monitoring of the volcano is also possible. Here you can see that this is the pre-eruption. So magma is there inside the crater of the volcano, and like here when this came up during the eruption, so this magma could be easily identified and detected. Now with the help of the PS-INSAR, PS-INSAR and SAR dataset, one will be able to do the volcanic eruption mapping and monitoring. Like during the volcanic eruption, there will be lot of gaseous eruptions as well as the cloud cover. So at that time, what will happen? It will become possible to get any information from the optical multispectral dataset. But now with the help of the SAR dataset, what we are going to get? We are going to get the clear view of the volcanic eruption, and the lava flow direction could also be detected. All the detailed information you can go through this material. Now the subsidence mapping and monitoring is also possible. Now with the help of the PS-INSAR technique, we will also able to get the subsidence, because this volcanic eruption was triggered due to the earthquake, and due to the different quakes, there was subsidence, and those subsidence were also detected. Now this is another study carried by Dr. Scott Hanley using UAV SAR data set to do the lava flow mapping and monitoring. So with the help of the airborne data set, they were able to find out the velocity that was approximately 34 centimeter per day. Now this has also been used for the early warnings in the context of the disaster risk management. So here you can see that the cyclone tracking is also possible. Here you can see that the center of the cyclone could be easily detected, and its velocity could also be estimated with the help of the multiple SAR data sets. And not only the cyclone tracking, its wind speed and wind direction could also be retrieved with the help of the SAR data set. Now SAR data set has also been widely used for the cryosphere and the glaciological applications. So for the snow density, glacier mapping and monitoring, sea ice monitoring, like here, this is the glacier flow speed mapping and monitoring. So here you can see that velocity, the red color is showing the very high velocity. So the very high velocity area could be easily detected with the help of the SAR data set. This map was generated by the Alaska Satellite Facility. Now we did this mapping and monitoring for the iceberg monitoring. So like with the help of the iceberg A68, with the help of the Sentinel-1 dataset, we mapped the iceberg A68, which was caught from the Larsen C ice shelf in July 2017. And here you can see that it is possible to see the entire trajectory. So we were, it was very interesting that it was revolving and it was moving in that direction. Actually, this came in focus when this started moving towards the South Georgia Island, which is the habitat of penguins and seals. So at that time, it was possibility that if it will hit the island, then there will be very big damage. But before hitting it, when it was near to the island, it was broken and dissolved in the water. Now, snow density retrieval is also possible with the help of the hybrid polarimetric RISAT-1 dataset for the Manali area. We retrieve the snow density, and it provided a very good accuracy with the help of the field dataset. Flood mapping and monitoring is also possible. Like one study we carried for the natural heritage site, UNESCO Natural World Heritage Site, that is the Kaziranga National Park. So Kaziranga Natural Park, we did this study to find out how much time flood is there. So this is the normal time period, means without flood. And when the flood entered in the month of July, so here you can see that the dark patches, they are increased. These are basically the water. So this was there till September, and after that in November we found that now again situation became normal. So here you can see that this is showing the animation in which it is showing that how flood entered and flood water is changing due to the different time period. Now, SAR dataset also been used for the oil spill mapping and monitoring, because oil spill detection it is not possible. It is difficult to retrieve from the optical multispectral, because the information of the oil spill will be merged with the background seawater. But in the case of SAR dataset, this is possible to detect the oil spill area. And a lot of work is going on in the oil spill detection, as well as its area, as well as people are working for the volume also. And SAR dataset has also been widely used for the ship mapping and monitoring, because ships could be easily identified as bright object in the sea surface. So number of ships, their velocity and direction could also be estimated. So here you can see in this slide, velocity is also possible to detect. I tried to cover all the possible areas. I will invite quickly 4 to 5 questions, or like any question is there. Otherwise, you can ask it to my email also. Thank you.
Thank you so much, sir, for your insightful talk on the relevance of SAR data analysis and its various applications. I'm sure that all the participants will be highly benefited by this talk. Thanks a lot for accepting our request to be a part of this workshop, and indeed, it was great honor to have you with us today. So participants, if you have any queries, you can ask now. I have enabled the mic for everyone. It will be helpful if you could raise your hand and unmute your mic and ask. Nagaraj R, sir. Sir, you can ask. Yes.
Good morning, sir.
Good morning.
Sir, my doubt is which band is useful for water mapping, and what will be the max scattered information for water depth and water type, sir?
Actually, generally, all the bands could be used to retrieve the water information. But generally, since this is a smooth surface horizontal feature, so vertical polarization will have more sensitivity for the water information retrieval in comparison to other channels. But when we are coming about the depth information, so depth actually, when the microwaves, when the water comes in picture, microwave is going to surrender, because like underwater is not possible with the help of the SAR dataset.
Thank you, sir. And what about water types, sir, like clear water or turbid water in the case? Any difference?
Yes, actually, if there will be any roughness in the surface due to the motion, like suppose in the sea surface, what will happen? There will be tides and waves and current. So those could be detected in the SAR data set.
Thank you, sir.
Thank you, sir. Shashank Shekhar, sir, you can ask your question.
Hello, am I audible?
Yes.
First of all, thank you so much, sir, for the great presentation. My question is, you talked about four polarization, that is HH, VV, HV, and VH. So my question is, when it comes to the visualization of satellite image, how can we visualize which polarization is in the satellite image, whether it is HH, HV, VH, or VV?
Actually, that information, like what is the polarization, that will be provided with SAR data only. That will be each polarization will be given as name as HH, SV, VH, and VB only. So that information will be there with the band only. And why we are using? Because different type of features, like vertical structure, like vertical features like urban buildings and others, they will have high sensitivity in horizontal polarization. And when we are coming to the vegetation, so vegetation, what is happening? Horizontal is transmitted, vertical is received. So there is complete change in the polarization. So that complete change in polarization is mainly occurring due to the volumetric scattering or the multiple reflection. Okay. So vegetation information is retrieved in the cross polarimetric channels like VH and HV. Okay. Similarly, horizontal features like smooth surfaces could be retrieved easily or in very effective manner by the polarization VV, vertically polarized transmitted and vertically received.
Thank you, sir. That was helpful.
Thank you, sir. Raghavendra, sir.
So it was a very enlightening and enriching presentation. So you mentioned about the drawbacks as such as in ionosphere there might be interference for the SAR. What are the other drawbacks?
Actually, each remote sensing technique is having its advantages and disadvantages. So SAR is having disadvantage, like it cannot go below water. Advantages we have already talked. And when it is coming to the ionosphere, so it will be affected by the ionospheric scintillation. Faraday rotation will be there, as well as when we are coming to the interferometry. So there may be path shortening due to the high refractive index that will be caused by the highly charged ions, as well as the path elongation in the troposphere, because when it will coming from the high refractive index and troposphere will have the low refractive index, so there will path elongation. So that will be added. So that, those errors could be easily removed nowadays. And it is not having the sensitivity for the color information. It is sensitive for the structural and electrical properties only.
Thank you, sir.
Thank you so much, sir. Rakesh Singh, sir. Just quickly, you can ask the question. We are exceeding the time. Rakesh Singh, sir.
Hello, am I audible?
Yeah, yes, sir. Yes, sir.
Oh, thank you, sir. It's a very enlightening lecture. And so actually, I would like to know about that, how we can utilize the SAR in the slope structure and in the co-seismic study. For example, land subsidence is also going on, and suddenly there is earthquake occur. So what technique means? In persistent scattering is will be useful, or means co-seismic one in SAR one?
For landslide, you were asking?
For both, sir. If in this region the landslide is subsidence is continuously also happening, and suddenly the earthquake occurred like this.
Okay, so there the successfully PS in SAR has been used. So from the PS in SAR, one can detect the area which is affected due to the land subsidence.
Okay, okay, sir. Thanks, sir.
Shashank, sir, I think rest of the questions we can take it in as a mail or something, because we are already exceeding time. We'll take up 1 or 2 questions more maximum. Shashank, sir, you can ask.
Okay, am I audible?
Yes,
Yes.
sir. Yes, sir. You can.
Good morning, sir. It's a wonderful presentation, sir. My name is Shashank. I'm a research scholar from Manipal University. Sir, my question is like, how can we use the SAR in the agriculture discipline, sir?
In agriculture, like crop mapping and monitoring, as well as their study for the different phenological stages, their growth mapping and monitoring, as well as the soil moisture estimation. So these studies have been done for the agricultural applications.
Thank you, sir. Thank you, sir.
Thank you, sir. Ashok Raj, sir, quickly you can ask your question. Ashok Raj, sir, are you there? Yes, sir.
Yeah, ma'am. Sir,
Your voice is breaking a
I have
bit.
okay, sir. I will precise. Which method is statistical method or analytical method is suitable for flood mapping in SAR?
For which mapping?
Flood mapping, sir.
Flat mapping. Flat surface.
Yeah, sir.
Flat surface. Actually, flat surface generally when we are talking about the roughness measurement, like surface roughness.
Okay.
So
Okay.
SAR data set is very highly sensitivity, have a high sensitivity for the surface roughness, particularly when we will use the short wavelength like X band data set. If this is airborne sensor and K band data acquisition is also possible. So K band data set will have the very good sensitivity for the surface roughness.
Hope the answer is clear for you, sir. Quickly to Abhishek, sir.
Okay, sir.
Is how SAR data can be used for mineral mapping for identifying any mineral exploration in terms of
mineral mapping. The SAR data set could not be used for the mineral mapping because for that purpose another technique, that is hyperspectral remote sensing, that is having very good sensitivity for the mineral mapping.
Okay, so we cannot use any bands, particular band, to get any kind of insights from the data.
Because minerals they will not have any like difference in the structural property as well as the difference in the electrical property. So it will become currently it is not possible, but studies just to see what we can get, those studies could be carried. But if there is no difference in electrical and structural property, it could not be done.
Okay, thank you, sir.
Okay, thank you, sir. I think rest of the questions we can take up as email or something. I could share your email ID with them, I guess.
Yes, sure.
Last question.
Okay, yeah, someone is at work. Please be quick.
Ma'am, sir, what will be the publicly available SAR images? Publicly available.
Currently, Sentinel-1 is freely available. The current data set also you can get for the Sentinel-1. Archive or past data set of ELOS Pulsar, ERS, InviSat, these are also freely available. And like when the NISR mission will be launched in 2024, that data set will also be freely available for the entire group.
Okay, like as of now, any Indian SAR images is possible, sir? Indian satellite.
Data freely available. Indian satellite. Yes. RISAT 1 and RISAT 1A, that is renamed as EOS-04. Those data sets are available. You can request to NRSC. You will have to forward the request to NRSC, National Remote Sensing Center, Hyderabad, because they are having the authority to distribute the data set.
Okay, thank you.
Thank you so much to all the participants. I'll share the email ID of sir. You can have other queries. You can post other queries to him via personal email ID and clear your doubts. Thank you so much for such an interactive session. Thank you so much, sir, for accepting our invite and being there with us and spending this much time with us. It was really an insightful speech, insightful talk. So many new knowledge we have gained in this area as well. Thank you so much. Shamlal, sir, you want to speak something? Otherwise, we'll move ahead.
No. Just thank you, sir. Thank you for your wonderful lecture.
Thank you, Dr. Shamlal and Dr. Shilpa, for inviting me for this talk. Thank you.
Thank you so much.
Thank you, sir.
Thank you, sir. So I think we can move ahead with the next talk. Avik sir has already joined us. Sir,